Hi, everyone. I'm Ronen Tamari, and with me is Francisco Carvalho. We're here to tell you about our program, Mosaic, Modular Open Science, AI, and Collective Intelligence, unlocking large-scale AI-augmented network research. So science today is overwhelmed by the complexity, scale, and urgency of the challenges it faces. And this is probably not new to any of you, but what is different this year is that AI is about to completely break the current system of science. Submissions are multiplying, quality is degrading, and reviewers can't even tell signal from slop anymore. Last year, 21% of peer reviews at a major AI conference were written by AI, and this is only going to get a lot worse. The problem with AI is that we're plugging it into the wrong system. The architecture of science is stuck in the 19th century. We have researchers working in isolation, papers that obscure their actual meaning that we heard about earlier, peer review that takes months or even years, publications that are optimized for citation rather than durable knowledge, and AI plugged into that just pushes the whole thing to its breaking point. Fortunately, something really interesting has been happening in the last few years. Social networks have unintentionally revealed a powerful new way and a new architecture of doing science. We call it large-scale networked research. It's really hard to do this justice in just 7 minutes, but here are a few examples showcasing some of the potential. So we're seeing high-stakes, informal peer review happening on social media. Not being designed for it, but meaningful discussions and retractions are happening that shape fields, and they're not even on the scientific record. We're seeing open networked collaboration. During COVID, 150 researchers self-organized on Twitter into an open drug discovery collaboration that resulted in a preclinical antiviral candidate. Researchers that participated said it was like a new way of working none of us realized was possible. And finally, there's the everyday magic of science social media. How many of you are on science Twitter? Okay, fair number. For those of us that are on science Twitter, we experience this every day. Here's Andy Matuszak, an influential computer scientist, writing in 2022, speaking about how Twitter improved the quality of his creative and intellectual conversations, more better ideas, and a greater sense of belonging. Later in the thread, he asked a really big if-true question. This design space is so unexplored. What might you create if you took this seriously as a job to be done, improving this kind of medium for science? And our big if-true thesis takes that question seriously. We think that an intentionally designed networked research medium will enable humans and agents to radically accelerate science breakthroughs. Mosaic is our 5-year, $30 million program to build AI-augmented network research at the speed and scale our biggest challenges demand. To achieve this vision, we'll build a networked research stack integrating 3 maturing capabilities: modular research tools, AI for modular research, and open social networks for research. Let's see how they address the issues with the current system. So instead of isolation, we have humans and agents collaborating on social networks. We have modular knowledge units that are faithful to the research process. We have peer and AI feedback happening in real time. Verified contributions are like GitHub pull requests, attributable and reusable. AI trained on this data amplifies knowledge instead of slop. The current system was being broken by AI. Network research is how we harness AI for accelerating discovery instead. So back to these 3 pillars, which are the program technical areas, and we'll go over each of them. First, modular research tools. So projects like discourse graphs and nanopublications. They modularize research into composable micro contributions, claims, questions, hypotheses, evidence. These are essential for making science scale. It's what Wikipedia and open source software needs as well, and it's the same we need for science. Modular research tools help researchers do better science. We're seeing really promising evidence from early deployments. So here's a recent pilot user reporting back that even in the limited time I've used discourse graphs, I've found huge improvements in my thinking and doing of science. And we're seeing this recurring over and over. Second pillar is AI for modular research. As opposed to papers, which omit the critical details, modular research provides the right API for AIs to reproduce and extend research. This more faithful record also provides AI with better training data. The third pillar is really the secret sauce of the program, harnessing open social networks for researchers. So as we've seen, social media is full of micro contributions without even being designed for it. But this requires open data. None of the Twitter magic I showed you would be possible on today's Twitter. These spaces aren't open anymore. The good news is that in 2024, we saw a big part of science Twitter reconstitute itself on Blue Sky, an open social network. Blue Sky runs on AT-Proto, which is a decentralized protocol that enables us to go beyond just recreating a science Twitter and actually building research-specific social apps and architecture. In 2025, we did just that. I co-founded the AT-Proto Science ecosystem, which now stewards dozens of independent science apps. Most of these are volunteer or bootstrap projects. They include annotation tools, research feeds, hopefully even Catalyze, which is Sandeep here in the room, building a crowdfunding platform for science. I also co-founded Cosmic, where we're building a curation network for researchers called Semble. Semble has more than 1,000 users and an active integration with discourse graphs that I'll show you in a second. So here you can see me creating a discourse graph link between two URLs. And basically what we've done is we've taken something that happens on, that you need special tools for, and we've actually created a social media experience around it. And we see actually people are really enjoying this. So we see just people and agents creating dozens of these connections every day. And we think it's suggestive for the potential for these kind of social media tools to actually drive modular research adoption. We aren't the only ones excited about ARPA-Proto. Collaborators in the modular publishing world wrote this after I introduced them to AT Protocol. The properties that make AT-Proto compelling for social networking are the same properties that the research community has been asking for. We have a unique but fleeting window. AI risks and institutional volatility are creating space for new infrastructure. AT-Proto science and modular research can step into that gap, but the projects are precarious and lack real funding. We can achieve critical mass with funding and ecosystem building, which is exactly the kind of big if true effort that catalytic philanthropy was designed for. So Mosaic is structured as a thesis-driven fund betting on modular research tools integrated with AI and ARPA-Proto. A central core team will build the tech and integrations and will drive adoption through ARPA-Proto science and pilot communities. Mosaic is structured in two phases. The first is a 10 million two-year blitz to prove viability. And the second phase is conditional on the success of the first. We'll focus on expanding achievements and scaling, reducing grant reliance. A word on us. We've spent over a decade building the products, ecosystems, and networks that Mosaic is rooted in. We've lived the brilliance and brokenness of science social media, and we know we're only scratching the surface. Ending on our advisor Sandeep Wai's words, the next century's breakthroughs will not come from lone geniuses or siloed labs, but from rebuilding the architecture of science itself. We think there's never been a better or emergent time to realize this vision, and we hope you'll join us in the effort. Thank you.